Hello everyone, and welcome to my journey of creating Mithra lighting toolbox. My name is Mehran Davoodi, and I'm a lighting technical director, and in this video I'm going to take you through what inspired me to start this project and how I went about designing and implementing it. You might be wondering why I decided to develop a lighting toolbox in the first place. To answer that, I must start with some of the technical challenges that I've faced in different lighting pipelines in my career as a lighting artist. Let's start with the first one: sequence-based lighting and propagation difficulties. In case you're unfamiliar with how a lighting pipeline works, the first thing we do is to try to identify shots within each sequence that look similar in terms of lighting. Then we pick the shot, usually with the widest field of view as the key shot or master shot, and we start doing our lighting in that shot. For example, in this sequence from Maya and the Three, this shot was picked as the master shot, and I started doing the lighting in this one before going to other shots. And once we're happy with the lighting and we get approval from the leads and the supervisors, we then propagate our lighting setup to the rest of the shots in the sequence, which are called the child shots or the children of that key. And this whole process is what we call sequence-based lighting. Now, if you use traditional digital content creation packages or DCCs like Autodesk Maya or Blender, the propagation can become a very time-consuming and manual process just because these applications were not designed for this kind of task. And that's why Sony Pictures ImageWorks developed a node-based lighting suite back in 2004 called Katana solely to address this problem. Katana was later acquired by Foundry, and that's how it was made accessible to other studios as well. And many years later, in 2019, Side Effects introduced a new addition to Houdini called Solaris, which does pretty much everything Katana does, plus more. And these tools are very efficient in lighting and propagation, and that's why some of the biggest names in the industry like Pixar, ILM, MPC, and many other studios have been using them for years. So we should always consider sequence-based lighting before developing any new tool for the lighting department. Let's imagine a scenario where we need to create dozens of lights, and the only way we can do that is by placing these lights one by one. And if they need to be adjusted or animated, we would have to animate them by hand individually. I personally had to set up a few key shots like that, and as you can imagine, that process can take a while. On top of that, if or when your lead or supervisor asks for changes, it'll take even more time to make those adjustments because of how complicated everything gets. And when you have hundreds of shots like that in a show, the wasted time really adds up. This is definitely one of the areas that we should improve. The third challenge on my list is complexity. And to be more specific, I'm referring to complex lighting scenarios. Situations where we have hundreds or thousands of lights, and sometimes to make life more difficult, they are animated as well. Creating this many lights, adjusting them, adding effects and animations can become incredibly more difficult, to the point that our current tools won't be able to handle them. And that's what exactly happened to Pixar when they were working on Toy Story 4. They had a set with dozens of carnival rides with over 10,000 lights. But because they needed to create certain effects and animations for them, they realized Katana won't be able to do that in a timely manner, so they took the lights that they had already created to Houdini and turned them into simple points and started animating the points. And once they were happy with the result, they had to take all those points back to Katana and figure out a way to control the lights based on the attributes of the points. I still remember how magical this movie felt when I saw it on the big screen. The result was absolutely amazing. but the process they had to go through was really complicated, and it involved multiple departments as well. Maybe we can improve that. As you might know, we have amazing tools in the VFX and animation industry that are excellent at what they do. Maya is great at animation, Katana does wonders in lighting, and almost nothing can beat Houdini when it comes to creating various types of effects. But these applications are not that great when it comes to communicating with each other, mostly because there has been no standard way of communication for them. That's why Pixar had to convert their lights to points when they took them from Katana to Houdini. After Pixar open sourced their Universal Scene Description technology, or in short USD, the call for a standard workflow has been gaining more traction in our industry. For example, Houdini Solaris was built on top of this technology, and Autodesk Maya, Blender, and Katana have recently added support for USD as well. So hopefully in the next couple of years, our favorite DCCs should become more compatible with each other. So these are the challenges that have inspired me to create a lighting toolbox that would hopefully improve this experience, especially in terms of enabling lighters to manage complex lighting scenarios with more ease. My aim is to maximize compatibility and automation while minimizing complexity. So I started my journey by setting a few objectives for the toolbox to guide me along the way. Using this toolbox, I want to be able to create a large number of lights based on pre-existing placeholders. I also want to be able to adjust the attributes of lights individually or in groups. I also want to be able to create effects for lights and sequence those effects together to create even more complex effects. And finally, I want the toolbox to be compatible with sequence-based lighting and USD workflow to make it as future-proof as possible. So with these objectives set, I divided the toolbox into a few different modules and set goals for each of them. I also created schematics to make sure that everything would work the way I had planned in my mind. This step was really challenging because I had to make major decisions about which parts of the toolbox should communicate with each other and how the flow of data should be managed. And the schematics and the connections between the modules changed a lot during the development of the project, either because I would hit dead ends or would find better ways of connecting and implementing them. I was also doing a lot of research at this point to see how other studios have tackled these challenges in the past, and I found a few articles and videos from Sony Pictures, DreamWorks, ILM, and Pixar that helped me quite a lot to better plan and execute my project. Moving forward, I started doing some simple tests in Maya, Blender, and Houdini Solaris that you can see here. I did these tests mostly to figure out which DCC would work best as the host for the toolbox, and eventually I ended up choosing Houdini Solaris because it's node-based, it supports sequence-based lighting, and it also runs Universal Scene Description under the hood. Finally, it was time to start developing the project, and I was very excited because I felt like I had done my planning and was ready to make progress. But soon I realized I had completely underestimated the complexity of the project because I didn't know Solaris that well, and I just assumed it would be very similar to the rest of Houdini. But it turns out, because of USD, it's actually very different. So it took me a while to learn Solaris and how to write code for that. About a month into the project, I finally got some of my code working in Solaris, and I knew it was far from perfect, and it looked really boring because every light was the same and they were all white and there was no randomization. but I was very happy that the code was actually working. I was using Xforms, which are similar to locators in Maya or empties in Blender, to create some placeholders for the lights, but it wasn't any better than creating lights manually. It wasn't saving me any time. As a matter of fact, it was probably slower, so I needed to find a better way. And to solve this issue, I started thinking about generating points using Houdini built-in nodes, which would also allow me to store useful information like color or intensity on the placeholders. Then I would use those points to instance the lights, which is a very common practice in Houdini, and this worked really well. This way was much faster, and I didn't have to create the placeholders one by one anymore. It also looked much better because I could store light attributes on the placeholders. And that's one way we can randomize attributes of lights, and the toolbox respects that as well. I was using Python programming language, which is usually fast and efficient, but because Houdini doesn't support multithreading for Python, my code was really slow. And I had two options: moving forward with Python and accepting that the toolbox will be slow, or starting over and using Houdini's own scripting language called Vex, which does support multithreading. Obviously, I knew I needed to bite the bullet and switch to Vex, so I did. And thankfully, this did improve the performance of the code by a factor of 16. So I kept working on the modules and doing various tests, but things were starting to get a bit out of control. Everything was scattered, different modules, different features, and I was having a difficult time trying to find everything. And that seemed like the perfect time to take a step back and think about creating the user interface and connecting everything together in an attempt to reorganize the project. I guess when it comes to designing the UI for this kind of project, the biggest challenge is trying to keep things simple and sensible. But I didn't want to put too much pressure on myself either, because this is the very first version of the UI and it'll change in the future for sure. I approached designing the UI the way I would normally do lighting. The first section should be dedicated to either creating lights or selecting what lights I want to edit. Once we have that, we can move to the next part, which allows us to adjust attributes of the lights that we just selected or created. The next section is for creating and managing effects, and because almost 90% of the effects module is going to be mathematical calculations, I decided to design the user interface for the module before I actually developed the code, just to make sure that everything is accounted for before I jump into coding. With that said, let's take a look at the first version of the toolbox in Houdini Solaris. To show you how the toolbox works, I've brought this asset back to Houdini Solaris and created the simple setup. I've also created some placeholders for the lights. Let me show you where they are. They're right here inside the submodify node. I'm using a bunch of Houdini nodes to generate these points, and it doesn't take more than a few minutes to create these. I'm also storing some color temperature values on top of these points, so we have some random color temperatures assigned to each placeholder. Once we create the lights, we should be able to see them. And at the very end of this network, we have this null node. It doesn't do anything, but it'll help us find these points. So basically, this is going to act like an address. Let's get back to the stage. Let me select my camera. And the way you can access the toolbox is like any other node in Houdini. You can hit tab on the keyboard and start typing the name. And there it is. We can create it right here. And it's already complaining because it's not connected to the stage. So let's take care of that. All right. So as you can see, we have this light manager. And inside this light manager, we have different sections: lights, attributes, effects, optimizer. And if we open lights, you see we can actually choose whether we want to create lights or we want to edit lights. Right now, I want to create lights for this building, so I'm going to keep it as is. And the first thing we need to provide the toolbox with is a path to the placeholders. And I'm going to use Mithra input, as you can see. So you can search for anything you like. You can say Mithra, and it shows you all the results that it finds. I'm interested in this Mithra input building lights. And the next thing is a path to a light primitive. So as you can see, the toolbox has two inputs. The second input is for the lights, and you can add as many lights as you like to the second input. I've already created this light for the building, and I'm going to use its path. Of course, I have to connect it to the toolbox, but I also need to use its path right here. And there they are. So we just created 80 lights based on the placeholders. But if you take a look at the reflections on the ground, you see all the lights are white, even though we did have color temperature attributes on the placeholders. The thing is, the lights that we create in Solaris by default don't use color temperature. So you can either enable them here on the light itself, and it's going to update it, and there we go. We have solved the issue. But you can also use the toolbox to adjust attributes. That's the second section of this light manager. So we can close this light section and we can go to the attributes. And as you can see, we have different attributes here. We can also define or access custom attributes. For example, if you're looking for a certain attribute from Redshift or from RenderMan, you can create or access them through custom attributes here. But fortunately, we already have color temperature right here, so we don't need to worry about the custom attributes. If I were to set the color to something else, let's say red, you can see that all of the lights are going to turn red. And if I were to set the color temperature to enabled, you can see that all of the lights are going to respect the color temperature values that we've put on the placeholders. And this is how the rendered version of this building looks like. Let's skip the color. We don't need to change the color. We just wanted to enable the color temperature. So that's how you create lights. We can also adjust the intensity and the exposure. We can set this to add, for example, and set the intensity to 10. Because we're setting the intensity mode to add, if we were to check our lights and find the intensity value, there it is. Right now it says 25. If I were to choose skip, it goes back to 15. We have different options here. We can subtract, and it only applies to the lights that you've selected or created here. All right, so let's skip that for now. We don't need to change the exposure. And I'm gonna pause the renderer. What if we wanted to edit some of these lights? Maybe I want to access 4 of them or 5 of them and change their colors. We can actually create more toolbox nodes, and under lights, instead of creating lights, we can change that to edit, and we can use Houdini viewport to select some of these lights, maybe this side of the building, let's say. We have some of these lights highlighted, and I can drag and drop them right here. Let me resume my renderer. And if I were to come here and maybe set the color to something else, again, this time let's go for blue. We should be able to see them, but we don't, because as you can remember, we said that we wanted to control the lights by color temperature. So I can come here and say, you know what, I've changed my mind. I don't want to enable color temperature anymore. And there we go. We are only adjusting these lights that we've selected. And we can always change that. If you wanted to select all of these lights, you can do that by using star at the end, and it selects all of them. Or you could select, specific lights that you want to change. I don't know which one is light number 14, but it should be somewhere. I can see it. I don't know where it is though. So yeah, that's how editing light works. By the way, if this naming system bothers you, you can actually fix the naming when you create the lights. For example, I can say, instead of Mithra lights 1, I want the lights to be under building lights. And I'm going to use the same name for the collection. And we can say each light should be named building light. And there we go. So all of that is now nice and tidy. Of course, because we've changed the names, this doesn't make sense anymore. We have to go and find building lights and building lights number 14. There we go. We can see that blue reflection right there. So this is how you can create and edit lights and adjust their attributes. In the next demo, I'm going to show you how the effects module and the sequencer work. Under the effects section of each light manager, you can define containers. And these containers will help you set up the overall timing, repetition, start pattern, and a few other time-related settings. Then you can add as many effects as you desire to these containers to control different channels. For example, you may have one container that starts on frame 1 and operates on the first 10% of the lights and repeats itself 5 times. And inside of it, it has 2 effects, one for the intensity channel and the other one for the color channel. So you can have multiple containers and each one can host multiple effects. And you can sequence them together and create many different types of effects. So I've set up the simple scene in Solaris and created a bunch of lights with the toolbox using the same technique that I showed you earlier. And now we can go ahead and create an effects container using the default settings. We're going to go through the settings in a moment, but first I want to create an effect to control the color of these lights. So let's do that. I'm going to create one effect, and as you can see, all the lights are turned off now because our effect is operating on the intensity channel, and it starts with a value of 0 and it goes to 1 in 48 frames. So if I were to play, this is the effect that we get, and once it finishes, it goes back to the default value. So we can probably change this to maybe 8, and then change the channel to color. I'm also going to use one of these presets, maybe Plasma. All right, let's go back to frame 1. And you can already see that starts with blue. Let's play that. It's very fast, and once it finishes this color transition, it goes back to the default value. But what if you wanted this effect to keep playing over and over again? Well, you can go back to the time settings under the container and change the repetition to cycle. And if I hit play, the effect is going to keep playing forever in this scene. But what if you wanted to introduce some delay? We can do that using this element offset value. Right now it's set to 0. That's why all the lights start at the same time. If I were to change that to 2, then it's going to wait 2 frames before it starts the next light. So let's hit play. And there we go. This already looks like carnival lights or casino lights. And right now, the moment a light finishes its color transition, it starts a new one. It doesn't wait for the rest of the lights, but we can change that behavior with this checkbox here. So we can ask the toolbox to wait for all the lights to finish before starting a new cycle. And if I do that, you can see it's a different behavior. This may or may not be what you want, but we certainly have that option. We also have mirrored repetition. Let's go back to frame 1, enable mirrored repetition. And once it reaches the end, it's going to come back from this side to where it started. Okay, I'm going to disable that for now. We also have the option to group lights. We can say maybe group by 4, and it's going to start grouping lights together. We also have the option to change the start pattern of these lights. Let me reset my group value. Right now, all of these lights are enabled for this effect. I can say maybe I only want the first 8 lights. So we can come here, we have different options. First N lights, and set the number to 8. So there we go. We only have the first 8 lights. We can also reverse the order of the lights, and it works with all of these options. We have that control as well, and all of these settings are just for one container. So imagine the creative control that you can get with using more containers and multiple effects within each container. Over here, I have a few more examples for you that I've already set up. Let's take a look at this one. This is a candle light effect that I've created. It is very simple. The lights move a little and they flicker. And in the next example, this is the effect that we have. And it's only using 2 containers. The first one is controlling the intensity of the light with some offset. So we have an offset of 2, and we have mirrored repetition, and we're waiting for all elements to finish before starting a new cycle. And in the second container, I'm controlling the color of the lights. And we can also take a look at the optimizer module. If we were to take a look at the lights that we have in the scene, we have 32 lights starting from 0 to 31. And during most of the effect, like we have probably 7 or 8 lights enabled right now, and the rest of them are turned off, but they are being rendered. And some renders, like Redshift, they do calculations even though a light may not be contributing to the scene. Now, we can enable this optimizer by clicking here, and as you can see, the effect doesn't change, but if we were to take a look at the list of lights, there are a lot fewer now. We only have 7 lights, and if I were to go to the next frame and continue moving forward, we see that we no longer render 32 lights. We are only using 7 or 8 lights, depending on the frame, to make this effect work. And this is a lot more efficient. This helps with the performance of the toolbox, and it also helps a lot with the render time. And this is how it looks when it's all rendered. And with that said, let's take things up a notch and see how the toolbox performs in a more practical project. For the final demo, I decided to work on the Eiffel Tower. I did some research about the lighting of the tower and learned that there are over 300 internal projectors that light up the tower from inside and give it its golden look. There are also 20,000 sparkling lights that were installed on the tower for the Millennium, and they were removed in 2001, but people liked them so much that they were reinstalled in 2003. We also have the light beams at the top, or the beacons. There are 4 of them. As they can't rotate more than 90 degrees, they have to be turned on 2x2 to give us that rotation effect. So all of this meant that I had a chance to test the toolbox in a real complex lighting scenario. I started with creating some placeholders for the lights, and here they are. We can go and take a look at them. I'm using the normal attribute to also set the direction of the lights. So these are going to be our internal projectors. And we also have the lights for the first floor. And we have the beacons at the top. There they are. We also have a few fillers for the antenna. And finally, we have our sparkling lights. Let me turn off the normals, and there they are. We have 20,000 lights that we're going to manage with the toolbox. And I'm going to go back to the stage. I've also created 5 lights. I'm going to use these lights in the toolbox to basically create the entire look. And if we take a look at the toolbox, I have 5 light managers for different parts. The first one is the sparkling lights. So I can enable that, and let me resume the renderer. We have our sparkling lights. I've already created the effect. If we go in the effects section, you can see that I've changed the start pattern to random with threshold, and I'm setting a threshold that indicates how many lights should be enabled on each frame. And the second light manager is responsible for the golden lights, or the internal projectors. The third one is for the gold lights, or the golden lights on the first floor. So let me go a bit closer to the tower so that we can see them better. It does take Redshift a little bit of time to resolve the render, but given the fact that we have thousands of lights in here, it's understandable. And we can work with the rest of Houdini very fast, so it's not really a problem. And there they are, these small lights. And moving forward, we have the beacons. So let me change the camera. We can see them. And if I go close to the antenna, we should be able to see the fillers as well. So this area is a little bit dark right now. I'm using a few fillers to light up that part as well. And this is the entire lighting setup for the Eiffel Tower. It took me about an hour to create the placeholders, which is not too bad, and about 5 minutes to set up the lighting. So overall, it was very fast. And also, the optimizer module has been incredibly effective for this project. The tower, without any of these additional lights, takes about 42 seconds to render. And when I enable the lights, but have the optimizer turned off, it takes 7 minutes and 18 seconds for each frame to render. But when you do enable the optimizer, it actually makes the render time 7.8 times faster and brings it back to 56 seconds. So it's been a lifesaver. I'm very impressed with the performance of the optimizer, even though it's a very simple module. It's been very effective. And this is how it looks when it's all rendered. Every step of this journey has had its unique challenges, but that's also why I've enjoyed working on this project, and I have plans to keep going and keep developing the toolbox and hopefully make the entire toolbox accessible to all 3D artists in the near future. And this brings us to the end of this presentation. Thank you so much for watching, and goodbye.